In 1999, Serbian radar crews were preparing for another wave of NATO strikes, but there were no explosions. In the middle of the night, substations across Belgrade began to fail in sequence. Power stations lost control. Air defense grids went offline. By morning, 70% of the country's electricity was gone, leaving millions in the dark. For 25 years, most militaries around the world dismissed it as a niche weapon, too limited and absolutely not worth the investment. Until summer 2025, when Chinese state media aired footage of something that looked disturbingly familiar. Now, the Blackout Bomb appears to be returning. In mid-2025, Chinese state media released footage of their latest next-generation weapon, a Blackout Bomb. Published by China Central Television, the video shows a missile lifting off from a land-based platform, climbing briefly before deploying nearly 100 cylindrical submunitions over a marked strike zone. The canisters bounce on impact, then burst mid-air in quick succession, releasing a hazy chemical cloud. Moments later, what appears to be an electrical grid flashes and then fails completely, all without a single high-explosive detonation. According to commentary accompanying the animated outage, the test scenario affected an area of roughly 2.5 acres, enough to blanket a mid-sized substation or cut power across several city blocks. While there is no official designation or deployment status provided about China's new weapon, according to the vague video, the munition has a listed range of 80 miles and carries a warhead weighing roughly 1,080 pounds. The footage credits the system to China Aerospace Science and Technology Corporation, CASC, a state-owned defense contractor closely tied to the Ministry of National Defense. Though the weapon was not named outright, its design, effect, and delivery method leave little doubt. This is a graphite bomb. Rather than relying on explosive force, graphite bombs disrupt through electrical overload. Most are built around a metal canister, tightly packed with conductive filament, coiled like spools of thread. Once released, the strands disperse in the air and drift downward, settling across exposed high-voltage systems. The instant electricity flows through one, it vaporizes, creating a thin channel of ionized gas, which draws even more current, expanding the arc and pushing the system past its threshold in seconds. Often referred to as blackout bombs or soft bombs, their effects are largely confined to electrical systems, with minimal immediate damage to surrounding infrastructure. Depending on grid configuration, a single strike can disable power at the facility level across a metropolitan region, or in tightly networked countries, potentially disrupt nationwide coverage. Graphite bombs, of course, are not new. Long before China showcased its Blackout Bomb, the United States had already tested and deployed similar weapons in conflicts across the globe. During the 1991 Operation Desert Storm, sea-launched Tomahawks carrying modified Kit-2 warheads streaked toward Iraqi power infrastructure in the opening hours of the air campaign, dispersing graphite strands across critical substations and transmission corridors that fed Baghdad's command network. Within 72 hours, post-strike assessments confirmed 85% of Iraq's electrical grid had gone dark. Though the Kit-2 operation remained classified for years and the payload never entered mass production, it represented the first combat use of a non-kinetic infrastructure weapon, proving conductive filaments could achieve strategic effects previously reserved for conventional bombing campaigns. By the time NATO aircraft entered Serbian airspace in 1999, the US had fielded a more refined version, the CBU-94. The system combined an SUU-66B tactical disperser with 202 Blue 114B submunitions, each containing 147 reels of carbon fiber wound tight and engineered to unravel mid-air. Small parachutes stabilized the descent, allowing the filaments to spread across exposed electrical infrastructure. On May 2, 1999, during Operation Allied Force, F-117 Nighthawks dropped these weapons on Serbian electrical facilities, disrupting more than 70% of the national grid in a single strike. Though Serbian crews restored partial power within 24 hours, the strikes had already degraded military response times and communications. A second wave on May 7th plunged the country back into darkness, demonstrating how sequential attacks could maintain operational pressure. The technology saw limited deployment during the 2003 Iraq invasion, targeting specific grid nodes to shape urban operations. By then, graphite weapons had proven their strategic value beyond simple power denial. they could control the tempo of conflict without the collateral damage of conventional strikes. But that's not to say there aren't detractors regarding this seemingly harmless weapon. Graphite weapons have generated controversy over their cascading effects. In previous conflicts, prolonged blackouts have triggered public health crises when water treatment plants and sewage systems went offline, particularly devastating in regions already lacking backup infrastructure. Nonetheless, graphite bombs seem to be making a comeback all over the world. In 2017, just hours before Kim Jong-un declared nuclear weapons a powerful deterrent, guaranteeing North Korean sovereignty, Seoul quietly unveiled its own Blackout Bomb program. Developed by South Korea's Agency for Defense Development, the weapon slots into Seoul's kill chain doctrine, a preemptive strike architecture designed to hit North Korean launch sites before missiles leave their paths. In 2020, the ADD brought in private contractors to build what military sources describe as, quote, a gliding graphite canister, engineered specifically for the peninsula's mountainous terrain and hardened northern targets. Unlike the American CBU-94 that carpets entire grid sections, South Korea's variant reportedly carries a smaller payload configured for concentrated strikes against specific substations and relay points. Budget documents suggest initial deployment by 2024, though operational status remains unconfirmed. If deployed, the system could plunge Pyongyang into darkness for days. Military command networks would go silent, water pumps would cease, and civilian hospitals running on already spotty power would face a complete blackout. However, North Korea's own electrical poverty creates an ironic defense. With their total consumption being roughly 1% of South Korea's per capita usage, there's simply less grid to target. Much more concerning, any attack of any kind, graphite or otherwise, would invite retaliation from Kim Jong-un and his followers. While South Korea's graphite program remains mostly under wraps, China has chosen a different approach, putting its own blackout bomb on full display. The broadcaster of the summer 2025 video of the new weapon offered no details about the weapon's designation or status, only referring to it as, quote, a mysterious type of domestically made missile. Because of this, it remains unclear which stage of development it has reached, or if it has already been deployed by the Chinese military. As it often happens with these types of releases, the footage of China's Blackout Bomb has sparked speculation about its intended target set, with online discourse toward Taiwan's electrical grid as a likely candidate in any future cross-strait conflict. Analysts note that the underlying concept is not new within military research circles in China. All the way back in 2017, writer Chen Chundi stated that graphite bombs are a major advancement in non-kinetic warfare. According to Chen, the objective of this type of technology, rather than neutralizing troops or hardware, is to completely freeze the supporting system that make modern militaries function, like command, control, communications, and surveillance. The author wrote that early Chinese variants of the weapon were already believed to be in service at the time, though with smaller payloads. Chen also suggested that future iterations could be paired with tail-mounted wind-corrected munitions dispensers and state-of-the-art satellite guidance, allowing operators to deploy the filaments over specific substation zones or high-voltage corridors with high precision. According to him, quote, in the future, this weapon will likely be adapted for Chinese cruise missiles, delivering devastating effects in wartime. If proven viable, a fully fledged blackout bomb system would add another tool to China's expanding portfolio of hybrid warfare capabilities. China's grid attacks could neutralize radar coverage, delay troop mobilization, and sever digital communications long before a missile or drone reaches its target. Taiwan's power grid is especially vulnerable, as the Financial Times reported in March 2024 that the island's energy network faces acute wartime risks tied to its heavy centralization, aging crisis response protocols, and overwhelming reliance on external energy sources. According to the report, more than 80% of Taiwan's electricity is generated using imported fossil fuels, creating multiple pressure points that could be exploited in a strategic disruption scenario. In practice, this means a well-timed attack on just a few key substations or relay corridors could produce widespread effects across the island, not because of any one technical failure, but due to the compounded fragility of the system itself. And while the Blackout Bomb may be aimed at Taiwan, it fits into a wider shift in how China engages with conflict around the world. The nation has also been a key ally to Russia during its full-scale war, helping Moscow evade Western sanctions and becoming the leading source of dual-use goods, fueling the Russian defense industry. With Taiwan's grid exposed and Russia's war offering a live-fire lesson in how to collapse infrastructure, China's message is becoming harder to ignore. War will no longer begin with an invasion. It will begin when the lights go out.